They say you don't gotta go home, but you can't stay here. And no, I don't wanna be alone.
What is up, people? Damn, sorry about the delay. I had some settings that didn't want to set like they were supposed to. But today's gonna be a fun one because I wanted to talk about some stuff that pretty much everyone needs to learn and figure out and be part of their argument, because one of the main things I like talking about is obviously gravity, and an argument that we've heard. I don't think I've heard it recently. Yeah, what's up? I don't think I've heard it recently, but I do know I've heard it. I think Chris Berry runs with it. We know Slick ran with it for a while. But the idea of gravity being an aspect of potential energy. That doesn't even make sense, right? I mean, is it me? I'll go ahead and put the link out there. Open this up. Like I said, it's late, so figure we'll just do open panel. Stay on topic, but open topic as well. And then we'll see where it goes. Because, like I said, this idea that potential energy could be why things fall. No. I can give you 101 examples of it, and I'm going to. I don't think I'm not. But one of the things that I really get confused by is the idea that, again, you're making up some random idea of how things work without explanation and saying no. You can't tell people no unless you have an actual idea what you're talking about. Otherwise, you're just saying words. So what I'm doing right now is I'm pulling up a couple things. What's up, sir? How you doing? Do you hear me?
Do you hear me?
I do hear you. How you doing, sir?
In a world of pain, but otherwise okay.
Well, that doesn't sound good. What the hell happened to you?
I slipped my disc.
Ooh, that definitely does not feel good. Never done it, but I know it hurts.
All that potential energy turned into kinetic energy and my disc moved.
Ain't that the truth? Let me see. I'm gonna try to share these real quick. Um, this way. Are you watching the watch page right now? You have that on your screen, right?
Yeah.
Okay, because I'm trying to figure out if I have to actually share it in here, but I don't. If you're watching that, where is my images? All right, guess I got to bring them up. Hang on 1 second. I'm gonna bring that here and here. There you go. So just throw those right up. I wanted to show these screens. I'm gonna have a quick explanation of something, and then we can talk about it. Here's why it cannot be potential energy. It's pretty simple. I thought about it the other night, but I've never heard the argument. If it was potential energy, which is where these objects gain the energy to fall back to its original, whatever, we wouldn't have a constant 9.8 meters per second squared. That's as simple as it is.
Yes, we would.
No, how? You ready? You ready?
Go ahead.
Okay.
Yeah.
So if it's potential energy, then the fall or acceleration of fall would be different in everything with different, depending on who picked it up. So if you are bigger than me and you picked it up, you're going to be able to produce more potential energy into that object than I would. So therefore, your object should then fall faster than mine.
Why would it fall faster? I also have more mass, meaning that I have more inertia. So I'm more difficult to get moving.
Yeah, but you have a lot more potential energy, and that acceleration down, you're not having anything that would be resisting you. So therefore, you would actually reach, I guess you would say you would reach terminal velocity faster? Or is
Nope.
that, wait, which one is it? Not terminal, is it?
No,
Velocity I'm thinking about?
I think you said what you meant to say. I'm just disagreeing because, again, I have more mass, therefore I have more inertia. I'm harder to accelerate. The force upon me is greater, right?
But it doesn't mean they're, okay, but it doesn't mean they're equal.
No, those things always always exactly balance each other out, right? That's what it means to say that gravity is proportional to mass. That everything accelerates at the same speed, at the same rate.
Mm-hmm. But then potential energy doesn't work the same, though.
Yes, it does.
How?
So, does it take more energy to move a 1 kilo weight or a 1 ton weight?
Depending on what you're trying to move it with.
Energy.
Well, what type of energy?
Any kind
a
of
small
energy.
amount of energy, or a large amount of energy?
Any kind of energy. Try.
Okay. Well,
So
if I
let's put it this way: use 100 joules of energy to move a 1 kilo weight and a 1 ton weight. Which one will end up moving faster?
say it one more time. I didn't get the first part.
It doesn't matter. I'm just saying use the same amount of energy to move a lighter thing and a heavier thing.
But that's not how potential energy works.
Potential energy turns into kinetic energy.
Okay, but doesn't it also matter how much potential energy goes into it to determine the kinetic energy?
It's the same thing.
How? So okay, so you asked how much energy would it take to move a 1 kilogram object? Okay, well, if you're an ant, you're going to need a lot of potential energy, aren't you? Compared to, say, an elephant.
What?
Different types of energy. If you have less energy, then how much potential energy can you possibly put into it?
Yes, but an ant will not have more energy than an elephant.
Exactly. Which means that the potential energy that can go into it is going to be different. Whereas in gravity, it would not be different.
It would.
Why?
It would be proportional. It would be proportional to the force.
Okay, so
And the force is proportional to the mass.
So
right?
if we're in a vacuum chamber, does an ant and an elephant accelerate the same rate?
Yes.
Yeah.
Okay. Well, then there you have it. You've already described how an ant and an elephant have different potential energies. So therefore,
They have
it couldn't be a consistent accelerated fall between the both of them with potential
they
energy.
they accelerate the same rate. The force acting upon them is not the same. The force is proportional to their mass. And the resistance to acceleration is also proportional to the mass. Therefore, they will accelerate at the same rate.
Even with the potential, you're talking potential energy, right?
Yes, but the potential energy is like one way of looking at how things have forces applied to them is through potential and kinetic energy, right?
Well, that's the energy that would be put into something, right? The amount of energy that could be put into something.
Potential energy is the energy of an object under strain. When an object wants to move in some direction and you resist it, you constrain it, right? You put it on a table and it wants to go down.
Or better, rubber band would be better.
A rubber band, a coil, a spring, gravity, magnetic attraction, repulsion, all of those will manifest as potential energy if you put them under strain.
Okay, perfect. So we're looking at those springs right now
Okay.
on screen. If I
Yeah.
put, let's say I put, oh, I can do this. That's perfect. So if I put this one, if I get this spring and I get it this, if I compress it this much, same size. Let's get rid of this one. Don't need this one. I gotta copy it and then paste it. Bam, there you go. Okay, so same size spring. I put, we'll say 100. I don't even know. Let's say use numbers. 100 pounds of fucking energy or potential or whatever. This one, I put this much. Which spring has more potential energy in it?
The left one.
Bigger. This one right
The
here.
one which is more compressed. Okay.
Okay.
The one which is more compressed.
Okay.
I'm watching it on live stream, which is with a delay.
Okay, sorry about that. Okay, so in this situation, we're using these springs as if they're on the roof, right?
What? Can you repeat that?
So if we're gonna go ahead and say, if we're using this as this is what replaces gravity, then what we're gonna say is that these things would actually be on the roof, springing you downwards. Remember, the potential energy is gravity right now.
Okay.
But wouldn't that be? So if we were experimenting with potential energy as gravity, wouldn't we put springs on the roof so that energy would
We
explain why they
wouldn't
go
use
down?
springs. Gravity doesn't work like springs.
But springs work like potential energy.
Yes. Everything that can be put under strain, everything that has a force acting upon it when you resist it, has potential energy.
Okay, so then
That does not mean that all forces suddenly act the same and everything becomes unified. An elastic force, an elastic potential energy is not the same as gravitational potential energy, is not the same as chemical potential energy,
Well, is it
is not the same as nuclear potential energy, and so on and so forth.
Well, is
Right?
it the same as just gravity itself?
What?
Is it the same as gravity itself? You said
Is it
they're all. You said gravitational or potential gravity, uh, elastic potential. Like those things aren't the same. Well,
those things aren't the same?
yeah. Okay. So would saying potential energy have be any kind of the same for how gravity works itself?
Well, there you can look at it that way, I guess.
Okay. Well, the same way that density is the reason things fall. Well, that's the same thing as potential, right? It just doesn't work. Doesn't make sense.
Oh, in that sense, no, no, no. Gravity is the cause of potential energy. Gravity is the force that creates potential energy when you resist it.
Gravitational potential energy.
Yes.
Okay, just not potential energy in general. I just wanted to, because I was just thinking a rubber band doesn't do that. So
There is, I don't know what potential energy in general is other than the thing that
well,
applies to all of the different kinds.
yeah, that's exactly what I meant. Okay, but so in a sense, so this is what I guess I'm trying to get at. Gravity works in a way that makes things accelerate at 9.8 meters per second squared. Obviously, it depends on the mass, but ultimately, everything without friction basically falls at the same rate. Could you say that with any type of potential energy in an experiment that you would do repeatable, would you get the same consistent accelerated fall?
Yes.
How? So those springs I have on screen, they're both gonna put the same amount of potential energy as each other?
No,
So then they can't be like gravity.
they are not like gravity. They are like
Because
springs. That's what I've been telling you.
yeah. But that's the thing though.
Okay.
If we're talking the way they say, if you, for instance, the lighter, our trusty lighter, you pick it up,
Okay.
you've put a certain amount of potential energy into that object. Thus, that's why it falls like it does. That's the potential energy argument. I know you've heard it before.
Um, I haven't. I've heard of the density one. I haven't heard of the potential energy one, but
Well,
I actually don't.
it's the
Well,
same thing. It's the same thing. The reason its density is because of the potential energy put into the object. But it's the same argument, but I've heard it used separately.
Are they arguing that density is some form of energy?
Yes. Or it has a vector. The same way weight, same way, something orbiting. Density
Yeah,
doesn't
but
have a
yeah,
direction. It doesn't do
but you
something.
don't
in,
have
in
you
your
don't have
example,
you don't have weight without gravity though.
They would say it's your density. Doesn't work, I know, but they say density. But then you throw in the wrench of, well, what about a apple and a rock that's smaller than an apple? Well, the rock's still denser, but it's smaller than the apple. See how that works? That's why density doesn't.
Well,
That's why density doesn't
you
work ultimately.
well density doesn't work for several reasons. Like you can have a tree that could be more dense than a rock, but that tree will fall into a river and float, and the rock will always sink to the bottom.
no, you cannot have something denser than a rock that will float.
Yeah, that's why I said a tree.
Trees float because they are less dense than water.
Oh, but I can show you a bunch of trees that are much larger, weigh a hell of a lot more than a rock, and float.
And they'll float. Yeah.
Okay, so in your example with the springs, the equivalence with gravitational potential energy would be an object held at a lower height and then at a higher height. right? Would be comparable to a spring which is less compressed and then more compressed.
How would that? Can you give me an example of this situation in gravity? Or not the situation. See, what I'm trying to do is grasp my head around how it could be potential energy, even though I know it can't. But when you're arguing as if that's.
Well, first of all, where does the energy come from in the density argument?
If we're talking in this situation, you're picking up a rock. You are putting the potential energy into the rock that will make it fall back to where it started. That's the argument.
The energy is coming from me to make it fall?
Yes. So if you don't put any energy into it, it does not leave where it starts.
Why is it on the ground in the first place?
I don't know. Say my argument. I'm just telling you how it goes.
Well, look, I understand. I remember a long time ago, man, you had an argument, and I tried to explain that without gravity, if you picked an object up on the ground, since there's no force acting upon it, if you let it go in midair, it should just stay there because there's no reason for it to fall back to the ground.
Yeah, but when we were having those conversations, in my mind, I was still trying to figure out if it could be atmospheric pressure. And atmospheric pressure in my brain still could work to a certain point.
That the atmospheric pressure would determine which direction it goes?
Yeah. In my mind, think of it this way. There is more atmosphere above you than there is below you. Thus meaning there is more atmosphere pushing from the above than anywhere else. I know.
That's not.
I know.
Oh, I was going to say, that's not right, because it's backwards. There's more atmosphere on the ground than there is above you. There's like no atmosphere.
I have learned that. I now understand how atmosphere works, and that's why it's not my argument. But if you want to play the what works game, atmospheric pressure does work to a certain point. Only a couple steps.
I don't see how it would dictate direction, though.
No. Again, in my brain, there's more above than there's at our feet. And I think there actually is in area, but not in volume. I get that. There is more atmosphere above us. It's not as volume. I said it right. I think I did. Pretty sure I said it right. Did I? If I didn't, tell me, damn it. I don't want to run around with that argument.
But it will come down to the same thing as density. You need a force which will have a direction to get anything, right? Mm-hmm. You can, like the relative density argument is basically buoyancy, and to get buoyancy, to get the stratification in density, you need to apply a force to it. Okay, the force of gravity. To get potential energy, you need a force to strain against, right? When you rise a rock, if there is no force pushing on the rock to go down, then you're just moving the rock. You're not giving it potential energy. You're just changing its location.
You'd have to demonstrate how you're transferring the energy by lifting it. You're transferring energy to it. I can understand if you were throwing it or pushing it.
Again, not my argument. Matter of fact, remember, I'm arguing for the fact that potential energy is impossible to replace gravity, and I kind of have a question that may do it. What direction, vector, is gravity?
It is 32 degrees sideways.
It's what? Depending on where you are, right, Barney? Right? It's depending on where you are?
Nah, it's down. Come on.
Okay, perfect. So, what is the direction of potential energy?
Energy does not have a direction. Energy is not a vector, it's a scalar.
There you go. That's why it can never replace gravity. And that's a pretty big deal too. This whole direction shit matters. Really matters when you're talking like rotation of the earth as well, right? The whole, well, for spinning I should feel it. Yes? No?
Well, since we're all in agreement here, I
Hmm?
guess we'll call it a show. I said, well, since we're all in agreement here, I guess we'll call it a show. Good night,
Oh.
Sean.
Oh, no, no, no. No, Barney. Because I do remember that I do like to run, a couple hours at least, and I think we're like 20 something minutes in. So no, we're not going anywhere. So how you doing on your research on the cons of geoengineering?
Not at all. I have
Oh
a
wait,
mile-long list of things that I need to do before I get to that.
and you're injured too. So, well,
I'm injured. I've got work to do. I've got Travis's observations to predict.
ooh,
I've got a couple of videos that I've been making
oh,
for a while now that I have to finish.
that happened like clockwork right there because I wanted to talk to Travis. Travis, you're gonna have to. There it is. But you are. Wait, no, you're good now. I was gonna say a sec. Wait, you had your window down and you rolled it up, huh?
No.
Oh, it was loud as shit a second ago. Now you're good. But I'm happy you're here because Travis, you've recently added some words to your vocabulary,
Okay.
like
Like
More
centripetal
words.
force?
like atmosphere, uh, mirages,
No. Mirages.
refraction.
Mirages. No. Mirages and refraction were always in my vocabulary.
You just wouldn't say them.
No, that's not true because again,
I have hours of recording of you saying the ether band is the ether band. Oh, and if you want me to get more detailed, you have to pay me.
yeah. Again, I talked about what the detailed means. Okay. When I go through the footage that I present on my channel, I use inferior mirage. I use Fata Morgana. I use superior mirage.
Okay.
I do all that on my channel.
So then we really are just talking atmospheric optics, atmospheric conditions. You just don't want to use that term. You don't want to be held down by the man's terms.
Look, when I first started into this study for myself, the only terms I knew were the miraging terms, right? So I didn't know, and one of the things that I thought about after our discussion yesterday was, like, do you have a reference where you can cite that atmospheric effect or atmospheric whatever you want to call it is a term, right?
Atmospheric optics? Oh, I have 1,000
Atmospheric
sites.
optics.
Oh,
Well, that's fine. That's fine. If
Did you want me to get them?
if you want, not, you don't have to get all 1,000 of them. Just. But when I first started looking into this, and again, as I was looking into making observations over a distance and trying to think about, okay, how would I talk about this, and what is being said, and what is not being said, and what might need to be said, I, for myself, felt comfortable with describing what I was seeing as I looked over distance, because, like, say for instance, today I had a boat on the water, and there was no miraging, but there was distortion, right? Or if you want to call that refraction, I still think that there's too generic of a term. But when I'm looking out over the distance and I just see an object that's not very clear and crisp because it's not in front of me, there's distance and there's ether band between us. There's atmosphere between us, right? I just, it just made sense to me to talk about the air. That's what ether means, right? And to talk about band, which represents a certain field of view that I'm looking through at that time.
You just cut out on my end.
Not the entire field of view of my 180 degrees. So, not the main,
You're
but
roboting
a
big
small,
time.
I say, okay, I'll go on mute for a little bit.
Yeah, or just like maybe refresh something like maybe it's where you're at, but yeah, you're just roboting big time. Yeah. So I mean, it's the same thing. I mean, for shits and giggles, you can call it Etherband, but I mean, to me, I don't even care that you call it Etherband. To tell you the truth, I don't mind at all. To me, it's more just okay. At least now we're on the same page. At least we know that for one, on screen we have atmospheric optics. It is real. It's definitely has everything to do with refraction.
So what does it say? What
says,
since I'm driving?
Okay, yeah, no worries. Atmospheric optics is a branch of optics and hang on, let me pull it up.
Photonics.
Hang on, because it's on my screen, but it's behind a bunch of stuff. Hang on. Okay, here we go. Trying to read off my notes, and it's not going to work.
While you're doing that, let me just reiterate what I was saying before about the band, right? The band is the reference to the field of view that I'm photographing
Your
at
horizon.
a particular moment.
The band is your horizon.
Okay, that's not the way I use it. It's
It's
the
not
entire.
The way, it's not the way you're using it. I know, but I am clarifying to people that are listening because you're not explaining what that band is.
I just was, Sean. Yes, I
know,
I was.
But
I was just.
But it's easier to say the horizon, isn't it?
It's not just the horizon.
It's not the horizon.
Okay, so there could be a boat on the horizon. There could be land behind the boat. It's that entire section. A band is a section, a field of view within the viewfinder of my camera. That little tiny square that I'm looking at, that is the band. It's a narrow reference point that's not the full 180 degrees that's before me if I'm looking with my naked eye straight ahead. Right?
Okay, you ready?
Okay.
Atmospheric optics is a branch of optics and phonics that studies how light behaves in the Earth's atmosphere. This is going to be included and understand natural occurring effects involving sunlight and the propagation and distortion of electromagnetic signals through air. So
Okay, I would say that's
a very broad term. Like
yeah.
It's not. Yeah, you're exactly. You're 100% right. That's what I've been saying. The ether band is. See how you just was like, well, that doesn't explain anything. You're right. This is just explaining a branch of optics and study.
Right, but
that's it.
But the
That's,
ether band, yeah. So what I'm doing with my photography is atmospheric optics. That's the broad, systematic category.
You're taking pictures. You're taking pictures of different types of atmospheric optics.
No, not according to what you just read. That atmospheric optics is a field of study.
Yeah, and in that field of study are atmospheric optics, refraction, different phenomena. No, yes, I'm serious. That's exactly what it does. That's what it does. It refraction and how light works on Earth is exactly what it is. I mean, I just read that. Look, the study of how light behaves in the Earth's atmosphere. Now, what would create mirages, refraction, which is a part of... See, even refraction is a broad term. You say refraction, there's like, what kind of refraction? Like, you have to get... The detail isn't pointless. The detail is very important. The detail makes sense of what you're saying.
Well, I would say that's the difference possibly, well, I suppose, between a brook, a creek, a stream, a river,
Mm-mm.
right? So
No.
those are different. Hold on.
Okay.
Those are different categories of flowing water, right? So if we're talking about flowing water, that's a category of refraction, right? So a mirage has refraction. An inferior mirage has refraction. A superior mirage has refraction. A fata morgana has refraction. It's just a different expression.
I would think that it'd be more the refraction is looming, or the refraction is inferior mirage. Isn't that how it would be said, though?
Well, didn't I just say that? A refraction. No, I would say
you kind of made it seem as if looming had refraction, whereas, and I would think it's refraction. The refraction is looming.
Okay, so you would have so you would have refraction, like say atmospheric optics, A, refraction, and then under refraction you've got looming, you've got inferior mirage, you've got superior mirage, you've got fata morgana. Okay, but see, I still to me that's potato.
And then directly under
potatoes.
But then directly under those are the explanations of those different mirages. So you see how that the tree of detail works in favor of explaining what it is. So what you're saying is looming, inferior mirages, all the optic. Those are optics of refraction. Those are things you're seeing due to refraction. Refraction is the way light acts in a median. Like it can't go the description before the before the observation.
Okay, I mean, I don't have a problem with what you're saying right now. I was looking at it from a little bit of I guess maybe a bass-ackwards way of saying that inferior mirage has refraction, a superior mirage has refraction. That's what I think I said last night. I said refraction happens all the time when you're looking through the ether band. It's always there. Refraction is always there. So
the ether band is atmosphere. It is atmospheric optics, and it is refraction.
Well, I would put it under the category of atmospheric optics since you brought that up.
Okay. All I want to do is clarify, man. I'm not even right now. I'm at the point now where it is pointless for me to tell you that it's not real, because what you are observing is in your brain at the ether band. But to clarify what the ether band is would make your argument stronger. Because before you explained it, it sounds as if you're saying the ether band circums all. The atmospheric shit isn't real. It is ether band, and it's really like, what is he trying to say? I actually understand what you're saying now.
Okay. Well, that's what I think happens when we have a healthy back and forth instead of an antagonist. Pugnacious in those instances. But again, just to clarify, the ether band for me is that field of vision through which I'm observing certain phenomena. Okay. And I can see different phenomena within the same day and even hour or 10 minutes by looking at something that's in proximity, right? So if I look at a boat and that boat is a quarter mile away and it's distorted, but there's no mirage, but it's not clear. I can't read the back of the boat. I can't read the name on the stern, right? That's an effect. But then that boat is then a mile away past that, and there's an inferior mirage. That's all within the same band, but the thing that's changed is the distance. Does that make sense?
Yeah. I'm switching things back to the knowledgeable terms so that it makes sense. But yes, I do get it.
Okay. All right. Where do we go from here?
Wherever you like, Travis. What do you want to talk about? This is the Travis Minute.
No. I can't remember what you and Barney were talking about. That's why I called in, because you guys said something about...
We were
I think
talking
you were talking about
about
density.
potential energy.
Oh, yeah. Potential energy. Yeah,
Or you could say alternatives for gravity.
Alternatives for gravity.
Do you believe in gravity? Do you wait?
Not
Let me say this better. Do you understand how gravity works?
Trying to think. Hold on, give me a second to try to collect my thoughts. Do I understand how gravity works? No.
Do you believe that when you let go of a thing, it will fall down?
Yes.
And you believe in gravity. Now,
No, that's not
what do
gravity.
you think?
I just asked you a question.
Now, what would be your explanation of gravity, or do you know of any others beyond?
It's gonna be density and buoyancy. It's going to be the weight of an object traveling through a medium.
Apple,
And
small
when
rock.
I say weight, I do not mean the force of gravity upon a mass. That's not what I mean by weight.
What is
What
weight?
do you mean by weight?
How, well, in a very generic sense, how much an object weighs due to its mass. So this is the way I understand it. Mass is to matter what volume is to liquid, right? It's the amount of space. Hold on. It's the amount of space and material that make up an object, right? I take up a certain amount of space and I'm made up of a certain amount of material. That's my mass. Okay? And that mass has weight. It can be measured. So weight is a measurement of the heaviness of an object, whatever that object might be.
Are you talking like that, Travis?
Because I don't live in that in your world, so I'm just talking.
You do live in my world. Stop.
What I meant by that was I don't use these terms, right? You know, like just like Etherband. Why did you use Etherband? Well, because I was just thinking of stuff, and I didn't know you guys had a term for this, so I just said Etherband. You know,
It's okay. You're being cautious and you're trying to be careful in what you say. That's fine. So, from my understanding, mass is literally inertia. It is by how much things resist movement, how much energy you need to expend to move them, or to change their momentum, or however you want to look at it, right?
So would you consider a bathroom scale a measurement of inertia?
No, I would. A bathroom scale is a measurement of weight, and it is using equivalence. The proper unit for weight is newtons, because weight is a force. But on Earth, on the surface of Earth, we use scales to calculate the mass of the thing, given that we know what the force on it is. If you take that same scale and take it to the moon, or take it just up, or it will show varying weights, it will claim that things have varying masses, right? Which is wrong.
Yeah, I mean, I that's just splitting the hair so much. Inertia, to me, inertia has to do with movement. You know, so weight is the resistance, is a part of my resistance. Like, you know, how much energy would you have to exert? This is what I think you guys were talking about earlier. How much energy would you have to exert if you wanted to push me 10 feet, right? So my weight has has a relationship to the inertia that you're going to measure. But so if I'm standing on a scale and I read 200 pounds, and then I step off the scale and you try to push me 10 feet, do you have to use 200 pounds of pressure?
Do I have to use 200 pounds of pressure?
That's how much I weigh, right? I weigh 200 pounds. So does it take 200 pounds of pressure to move me?
No, but the speed that you pick up from the same amount of force will be proportional to your mass, right? So if I make a spring and then use that spring to push a small ball and push you, the small ball will accumulate speed much faster, right? It will move much faster. It will be easier to move it with that spring than to move you. Do you understand what I'm saying?
Sure, yeah. If you think about a pinball,
that difference will be proportional to your masses, and that is what we call inertia.
Okay, I'm fine with that.
Right. So that's mass for me, and weight is the force exerted by mass in a gravitational field.
Well, it's potential force per se. It's potential energy, because if it's not if it's not in motion, there's no force.
What
right?
do you mean?
Well, if an apple is suspended by its stem, there's no force.
Yes, there is.
You're talking
there is no normal force. There is no how do you say it? All of the forces, it is in equilibrium, right? The tension of the stem.
It's a potential force.
The tension of the stem is exerting equal and opposite force to the. Yes, but to the pull of gravity. When I'm talking about weight, I'm talking about that pull of gravity, right?
Right.
And that's what your scales, what your what is the scale? Is scales the right word? What do you use to measure weight?
Yeah, scale.
A scale, right?
Yes.
That's what your scale will measure.
Yeah. So if you were a part of the flat Earth debate last year, probably early last year, when Mark Doxey and I were on the show pretty much on a regular basis, he and I went toe-to-toe with this, where I brought up my coconut on an island analogy, and that is that he and I are on an island, and we see a coconut fall, and I attribute the fall to its weight, and he said, well, no, there was a force pulling it down. And I would say, well, where is it? Why would you even add this idea of force when we know that when I pick up the coconut, I can feel its weight? This is why it fell. He's like, no, there's a force that was attracting it to the earth. And I would say, okay, so where do you see this? How do you know that there's a force there?
Because weight is a force.
Then it's not gravity. It's the inherent intrinsic weight of that object. That's all it is. There's no reason.
Weight literally is the force of gravity.
That's what I said earlier, that I don't define weight as. I don't need gravity to define weight.
No. You can define, instead of defining weight instead of using gravity to define weight, you can use weight to define gravity. Those two things are identical.
Yeah, to me that's semantics, and I don't need. I don't need to have that. That
definitely does.
No, I know why you. I know why you say it does.
Okay, then what?
But
how do you have weight?
Because something exists.
Yeah.
When you say when you pick something up, you feel its weight.
Right.
To feel its weight, it needs to exert a force on your hand.
That's the weight.
Yes,
But there's nothing
weight
pulling that.
weight is the force of gravity.
But there's
If-
nothing
Yeah,
pulling
if there was nothing
the
pulling it,
object.
if there was nothing pulling
The-
it, it would have no weight in your hand.
No, there's nothing pulling it.
Then there'd be
No.
no weight in your hand.
No, that's not true.
It is true.
Seriously, look up what the
I'm not
formula
gonna
for
look
weight
up-
is.
no, I'm
Look
not
up
gonna
what the
look up your-
unit for weight is.
No, I'm not going to look up your formula that includes
It's
your
not. No. I'm not
construct.
giving you a formula. That's precisely why I'm
or
not
your
giving it to you.
definition or your definition or whatever. So what you're doing right now, Barney, is like I had a really long argument on Jose's Flip Flop show with another Christian where we hijacked the stream with permission because everybody was interested in the discussion, and I went toe to toe with this guy on interpreting the Bible, and he said you need to read X, Y, and Z. I'm like, I am not going to read your model. I don't need to read your model. I reject your model. So there's no reason why. No, you need to understand these. No. I understand these terms. And when you say, well, you need to understand this. No, if I were to read that book, all that book would be doing would be giving me the propaganda of
Which book?
No, I'm just being generic.
I didn't give you a book to read. I told you to look up what the word means. By
Right.
whichever means you I didn't give you a book, I didn't give you a reference, I didn't say go to a physics
Okay.
lecture, I didn't say read Feynman's book on physics.
I understand.
Right?
Well, let me try to be more clear then, Barney.
Okay.
The failure to communicate is on me right now. So what I'm saying is that when I say I'm using this as an analogy. When I'm talking to James and I say to James, the new heavens and the new earth has already come, and he says, well, you need to look up the definition of new heavens and the new earth. And I'm going to say to him this: why would I look up your definition? Because your definition is not going to be my definition. They're not going to be the same.
Can I ask you something? Can I ask you something?
Yeah.
If I'm going to tell you, okay, I have a Snowski. Ready? It's red, edible, has a little leaf on the top, it's green, little stem. They didn't even name a city after it. What is a Fathom?
You're using terms that I'm not familiar with, Sean.
Yeah, but I'm describing the same damn thing, you know. Fucking apple.
Except I don't use gravity in my concept
Here's
of
the thing.
weight.
Here's the reason I said that. Whatever you want to call whatever it is, you can call it whatever you want. But you are describing gravity, you are describing atmospheric optics, you are describing refraction, you're describing inferior mirage, etc., etc. The fact that you use different terms does not change what we are observing.
Okay, I don't have a problem with that because, again, then my response would be, right, we're talking about these observations and measurements on a flat Earth. That's fine. Okay, I'm good with
We're
that.
talking about on a globe. You have no proof or evidence for a flat Earth.
Yes, I do. Yes, I do, Sean. Yes, we all do.
No,
Yes.
you all don't.
Yes, we do.
Okay, so would you consider a refraction a flat Earth evidence?
I would consider refraction as an alternative explanation for the phenomenon of what is typically called or attributed to boats going over the curve.
No.
Okay? The
No.
physical... Hold
Nope.
on.
Can you show me a
don't
citation?
Tell me no.
Yeah, can you show me a citation?
That's
No citations. Don't
That's
call
what
for
I'm
a
here for,
citation.
Sean.
I want something that says that refraction
Right.
has to do with obstruction.
Okay, listen to me. Right. It's not out there, Sean. Just like James when he says you're using this term in a way that I'm not familiar with. If you look up any Christian reference to this term, they're all going to tell you what it is. And I'm saying, right, they need to be changed. So that's what I'm here for, Sean. I'm here to change the discussion, and I'm here to bring in an aspect of the discussion that's not being discussed, but it's still out there because refraction is out there, inferior mirages are out there. But those phenomena are the obstruction, not curve.
Okay, in that case, I'm here to be taught by you. What is weight, and what is the appropriate unit to use for describing weight?
Oh, why are you changing a field that I don't have, expertise in? I mean, you use the term Newton.
No, I'm asking you for your understanding. I'm not.
Well, I just use pounds and ounces, Barney. I mean, if we're talking about matter, right? Pounds and ounces. If we're talking about liquid, we would talk about ounces still, but then liters, right? So there's a difference between liquid measurements and solid or dry measurements. So then we get to pounds and kilograms.
Does liquid have weight?
Yes.
Yes. Do solids have volume?
Yes.
Then why are you? Okay, never mind. Maybe I'm misunderstanding something.
Well, I said earlier that solids or matter. I think I was using mass as a dry reference to volume, because volume. I was just thinking of the difference between liquids and dry goods, but I suppose volume. I see. Here's where it's flexible, right? I guess I would say water does have mass, and an apple does have volume. So I guess it's interchangeable to a certain extent.
Okay, so what would be the appropriate unit for mass then?
I don't think that I would disagree with any references that we have right now. Ounces, pounds, liters, fluid ounces.
So mass and weight are the same thing?
No, I tried to say that earlier, that mass is the material and space that the object takes up. So a certain apple might be, I don't know, whatever makes up the matter of an apple, and then its size. That's its constituent parts, its size and its material. And then if you measured it in terms of weight, you'd get 6 ounces. But the mass is...
No, so you said mass is its volume, right? It is its material.
The space that it takes up, and then that which constitutes its...
And weight is how heavy it is.
Right.
And both of them are measured in pounds and ounces.
Sure. Yeah.
How is volume measured in pounds and ounces?
Well, I don't know. I'm trying to think of making pancakes with my daughter this weekend, right? So she measured out dry in a different measurement, right? Then she measured out the liquid. They're measured out in different containers, because those containers have been marked off for different volumes, so that you're not going to take up the same amount of space with 2 cups of flour and a cup and a quarter of milk. That's not going to take up the same amount of volume. It's going to be different, right? But on both of them, there were the designation of ounces. So you can either measure out a cup and a quarter of milk, or you can measure out 6.5 ounces. Those are 2 different ways. I'm just being generic. 2 different ways of measuring.
Fair enough. Okay, you're using cooking norms for your measurements of volume, mass, and weight. I'm trying to wrap my head around mass being volume, but yeah, I see what you mean. For you, mass is literally just material, right? It is the physical
the amount of space. Yeah, and the amount of space that material takes up.
So when you take 1 kilo of lead and 1 kilo of feathers, do they have the same mass?
No, they're not. They're not made up of the same material. No.
They're not made up of the same material.
Right. Unless you have lead feathers.
They just happen to weigh the same. Okay. Yeah, that's you're using the words weight, mass, volume, material in a way which is distinctly foreign to me. I don't know what I would do with that.
Okay.
I would my instinct is that would hinder me in thinking about these things. It is in part due to my education that those things are part of a much larger structure where they have their place and they're connected to each other, and each of those informs you in some way about the others, and they're fairly rigorous, fairly specific. Where in cooking, yeah, for liquids you can approximate weight by volume, and I have a measuring cup which has volumes, but it will also have separate columns for weights, which will be indicated as flour, sugar. Yes, you will.
Well, they have
That's
different.
that's
They have
that's
different
literally
measurements.
They have different measurements. No, you can use a cup of flour in your recipe for pancakes.
No, I know you can, but what I'm saying is that unless I'm misunderstanding why I have a glass Pyrex cup, right? It's glass and it has a handle on it, and I can
Yeah.
pour out the liquid, right? But I'm
Yeah.
not gonna use that to measure out my flour. I have a scoop that's measured out as a cup or 3/4 cup or a quarter cup or a half a cup. That's what I'm going to use for dry.
No, so I have a Pyrex one which is glass. I have a plastic measuring cup which has indicated, as I said, flour, sugar, blah, and like by weight, and a separate line for
Right.
volumes.
So the
And you will
measuring
just
cup.
take a bunch of flour and shake it until it becomes level, so that you can read out how much you've put in
Right.
there, and then
But
add a
my
bit more.
question is to you. My question is to you. Would you use that to measure out a cup of water?
Yes.
Okay. It was my understanding that those were different measurements, but I could be wrong.
No, that's what I'm saying. You can things of known density can be measured out. Their weight can be measured out by volume, right?
It was my understanding that liquid volume and dry volume are measured differently. That's why you have different measurements for them, different containers for them. That was
No,
my understanding.
no. All you have to know is the density of the thing that you're measuring.
I don't know the density of flour when I'm measuring it.
Yes, that's why you have these cups that have it already indexed, where you have separate.
Okay. Again, just for clarity's sake, a dry measurement of 1 cup, you're saying, would yield the same density for a liquid as well? So, so if you had a dry cup measurement full of milk and a dry cup measurement full of flour, they have the same density?
No.
Then how do you know what their density is?
Here, it might be easiest to show you.
I mean, I don't know if this is a complete rabbit trail because I don't care about density when I'm making a cake. I'm not thinking about density.
No, but you care about mass for solid things and oh, come on. Open image in new tab. That's the one that I want.
In the chat, Travis, for you. I put it in here. It was a pretty simple one. It was what weighs more, a pound of feathers or a pound of lead? And then
Oh, what the hell is going on?
hang on. And then which is denser?
They both weigh the same, and the lead is more dense.
So then density has nothing to do with weight.
Did I say that it did?
Yeah. You said it wasn't gravity. And you did say density and buoyancy, I believe you said.
Okay, so I'm trying to figure out what I'm missing with your
You
what you're
said
trying to make. What you're trying to get me to understand.
I'll explain after Barney's.
Can you see my screen share?
Yeah.
Right? It's a measuring cup. On one side, it has water in milliliters, right?
Right.
And it has indicators for flour and sugar in grams. If you fill it up to that line with flour, it will weigh that many grams.
No, I get that.
Okay.
But then you have two different designations on that same container for different material. That's my point.
For flour and sugar will be different because they have different density.
I don't think that it's by density. I guess whatever. Okay, I just never thought of it that way.
Density is mass over volume, right? So if something has a fixed density and you take a certain volume of it, then you will know its mass without weighing it.
Yeah, I'd have to think about that. Okay.
Okay.
Sorry, I'm doing my paperwork.
That's okay.
I hate having to record my mileage. It's tedious and stupid.
Okay. That's enough silence for me. I'm gonna head out and get to work. Bye, Sean. Bye, Travis.
See you, Barney. Thanks for the chat. Am I the only one here besides you, Sean? Am I the only one here? Gary, are you here, Gary? Why am I'm by myself? I don't like being by myself. Alright, I'm out.
All right. So, what the hell happened? I left for 2 minutes, and all of a sudden, all shit hits the fan. How long has it been like that? All right. So I have no idea what happened to them on the panel. Unless someone wants to clue me in. Someone's still got to be out there. Let's see. I don't know. So I don't know what the hell just happened. I do apologize. I'm not really sure where they went. I stepped away from the computer, so I guess. Yeah, I know. I didn't think they all of a sudden did something happen. Did Travis rage quit? What happened? Ah. Okay. Well, that's my fault then. I apologize. Not really sure where they left off because, like I said, I wasn't at the computer. But hey, shit happens. I'm at my shit. It's only at an hour. Yeah. So I guess I'll just clue you guys in on a few things before I finish up. So I was called out last night by Multi Tom Tom. He pretends like he's gonna come on the panel to debate me. So we'll see how that goes. I'm not sure if anyone's heard Multi Tom Tom debate. He doesn't do it very often, but he has in the past. Don't expect much. It won't be pretty. It won't be factual from his side at all. But it's been a long time, and he aggravates me, so I guess I can do that. What else is going down? I got a couple uploads. Let's make that work. So please like and share those when you see them. I may just do a premiere. I'm not 100% sure. I may just do it over Arwen. We'll see. But yeah, I'm gonna go ahead and get out of here. And yeah, and I don't think I'll show you. You know, Multi Tom Tom. You've heard him. It's a special argument. It's kind of like a mix between Nathan, Dell, and Spurs without saying much. It's weird. Yeah, it's a weird one. I know what I want to talk about. I was listening to Jose's today, and actually, really liked what he had to say about the topics and changing of the topics. Again, in my opinion, today's topic, just as any of the other ones that are going to start going down, they're going to be topic based for knowledge, for understanding. It doesn't have to be for the shape of the earth. Travis was here, so I kind of had to equate it with it. But the idea of atmospheric optics and refraction and how these things work, I'm just learning more and more about it. So the more I learn about it, the more I want to talk about it. I had a comment in my chat, in my comments area, after yesterday's live stream, and the person said that refraction. Or let me actually go there. That'll be better. Let me see. Okay, so the person said. Okay, so it's fight the deception. And this is kind of where I think a lot of this happens because, again, if you're not, first of all, you don't understand how I explain it or what I was saying, it's kind of going to happen. So I do appreciate fight the deception, saying something in the comments rather than saying it to people in the chat where I didn't see it. It says, Sean G, fraction cannot explain it. And I'll tell you why, because it reoccurs on a cycle. No matter what the atmospheric conditions are, we can predict it to occur for thousands of years before the globe was accepted. Eclipses are predicted completely ignoring refraction, and I agree. And I said that. I said you're correct with refraction not having to do with the predicting of an eclipse, which I never said, but the Selenian. The situation of the Selenian eclipse Refraction explains why we see them. It has nothing to do with the predictions of or how they predict them. It's only to explain why during that phenomena do we see the sun and the moon above the horizon. Refraction explains that, not the prediction. And I mean, I got a bunch more. If you guys go to my comments for probably the past 3 streams now, you'll probably end up seeing Gleam in there. He likes to write novels. Trying to find another question or something that had to do with the stream I just found to be interesting. Not really. Let's see. Try to find at least a decent, half-assed decent one, right? Usually get a few. Yes. Lately, it's just been a lot of people asking about Travis about the ether ban, stuff like that. Trying to find one. Usually, I get a good militant one. Yeah, I can't find any. I'm broke through enough. So I'm gonna get out of here. Unfortunately, the stream kind of ended abruptly. I do apologize for that again. If you did make it through that 10 minutes of silence, thank you. Otherwise, I'll talk to you guys later. Tomorrow, I have an idea for a couple of experiments and things you and viewings or presentations that I wanted to show you guys for basically how I started to understand these topics rather than just hearing them and repeating them. And then also I have I have big news about the geoengineering stuff. I'll probably do that. I'm gonna do that at the beginning of the stream, so please be there for that. And then yeah, so tomorrow's gonna be one of the big streams that I'm gonna be presenting. Again, the first part will be geoengineering, which is going to be the big part. There's big news on front, where they're going to do it, when they're going to do it, and what the projections of these models, climate models, what are the opinions of the science. I think I've been on the right track of the cons of it, where some people are thinking, it's the development of technology, the idea of solution. Well, again, if the idea of solution and the survival of humanity matters, then you're going to shy away from the things that show more risk than reward. And that's what they're not saying. That's not what they're not presenting the studies that actually do that. So tomorrow's gonna be a big one. I know I've been saying I'm gonna do a bunch of them, but I actually waited purposely because this is going to be the big one that I wanted to talk about. So I do hope everyone shows again, and I do appreciate the people that are still here listening in, and I will see you guys tomorrow. Okay, wait. I've decided, for those of you some odd reason still here, I've decided you guys get to see a sneak peek of the new intro. This is a draft. This is part 3 of 4 parts that I gotta still connect. So this is a small snippet. that still be edited. But I'm gonna let you guys check it out because hey, you're still here, and why not? So I'm going to go ahead and throw this up for you guys. That's why you guys gonna enjoy it. See if I can get the right screen on here. That will be there it is. You guys get to see the editor. So there we go. Like I said, just small snippets. But hey, why not?